Yeah, but we have, like, I think some of this will get called acquisition. Yeah, I think the kind of factors which are like, if you get like that, it depends on what you mean by RIT, but you put RIT to evaluate it, just the same RPC, I guess, is higher. So we just put it in yeah. Because right now, no one so we have quite a lot of things to better in last, but not everything is it's bad.
Is it coding you or is it coding?
No, so yeah, we'll do like this. And that's why. That's why I said I'm more interested in because right now, Perth does not make any million on or actually, probably says like you cannot be like and no, but one is that, and second is the rate between demands, but it's less than so you can do ratings anyway, including the layer. So it depends on like what Google and everyone's gonna say, and then there's no one because I like it. So like that's what we mean. There's this person who is on stage. So all the on the language so then you just say everyone, like big, the small one, small, or whatever. Basically, whenever we have that, I mean, is my opinion. But yeah, like how I just yeah, okay, but that will stop. Because I'm free for all of these now. If I find it not out of and now it's yes. I think other questions will remain because there's nothing maybe but there's a delay.
Okay, good morning, everyone. I think we are getting ready to start. So welcome to the Rmcat session. So I'm Anna Brunström. My co-chair Colin Perkins is sending the blue sheets around. So please fill those out. You have all seen the note well, I hope. So take care. It applies, of course, to this meeting as well. Administrative points. Do we have a note taker? Volunteer note taker. You're doing it so well, Alan, so thank you. And we have anyone on Jabber? Use Jabber? Thanks, you said. Okay, the agenda has been circulated, so we have not such a long agenda today. So we'll start with the status update on the different documents. Then we have a discussion on the feedback design team and the progress there. And then we would like to discuss, as we are now starting to finish up our initial experimental candidate algorithms and the associated drafts, how we should proceed from there to take our algorithms further to proposed standards and the evaluation steps that we see there, because that is the next things that is coming up for the working group, and where we need to kind of agree on how to evaluate and assess those algorithms. So the working group document status. So we have the candidate algorithms. So the coupled CC algorithm has been submitted to the IESG. The shared bottleneck detection has passed the working group last call, and there's been quite some discussion from the feedback that came there. I think all those issues are now resolved, and David has updated the draft also earlier this month. So this one is now progressing into write-up. The Scream draft is ready. I don't know if Martin has pushed the button yet, but everything is done there. Okay, so, but I saw that Ingmar or you submitted update to fix the ID nits that were there. So it's
Yeah, Jahed. Yeah, we fixed the ID needs, and I think according to Martin, then it will be ready for pushing the next button.
yeah, Martin already did the write-up for it, so it was just that it got stuck on those parts. Then we have the NADA algorithm that was out in working group last call for a while. We now have gotten some feedback back on that algorithm. So the authors will make an update based on that, and then that draft is also ready to proceed. And then we have the GCC congestion control, and that is still waiting with the authors to continue and resolve the issues that has been with that draft for a while related to the handling of loss. Our requirements draft is still stuck, waiting in the editor's queue. But I guess eventually it will be moving forward. Then we have the evaluation drafts. And those, I think, are now the ones we need to start also get out after the candidate algorithm drafts have been moved on. So the eval test, we discussed this draft at the virtual interim. So the eval test was ready for working group last call. Then the eval criteria, there was some outstanding issue with the TCP part there that you were looking at, Varun.
Varun Singh. Yeah, so I think we've changed the evaluation for the TCP model for the short, but we've not published it yet. I think we'll probably have to send it to the mailing list just to see if everyone agrees with the new model. We'll do this today or tomorrow.
Okay, very good. Because
so beyond that, I think there's nothing else open in the draft, as far as I remember.
No, I think this was the only outstanding point that needed to be resolved, and we wanted to send the eval test and the eval criteria together for working group last call, as they are so closely related, so that people can look at both of them and see that they are in sync.
Okay.
So that's as soon as we have the update for that one, we can move both of those to working group last call. And then we will, of course, need some reviewers for those drafts. So we've had a little bit of not so much review enthusiasm in the last drafts that have been circulated. So please try and help review those. And I think it would be very good also, we have different authors on the two and they need to be in sync. So if you can also review each other's drafts to see that.
Yeah, I think the review is appreciated. I would say the eval test, of course, has been implemented by several people. So I would be much more confident about the correctness of actually both the drafts, because we move things between. So people have to actually implement part of the eval test by reading eval criteria. So, and some things have been pointed out in the past based on implementers' experience. So I would believe that I'm much more confident in the correctness of those drafts, but reviews are much appreciated.
Yeah, I think they are both in good shape. But I mean, also even, when we send the working group last call, even if you have used them and implemented them and seen that they worked well, just confirming that on the list is good input.
Yeah, Mia Kuliman as a former chair. So those have been around for a while and are pretty ready. So I think we got already a couple of reviews in the past. So just checking in last call is probably the right thing to do.
Yeah.
I wouldn't be too worried. That's what I'm saying.
Yep. Yeah. Then we have the wireless tests, and this one there are also no open issues in the draft as far as we have determined, but that one has not been used as extensively. So I think there we're looking for reviews and also for people to try it out and use it. Okay, Randall, you're up.
Hi, not sure you can see me, but it doesn't matter. The Randall Jessup Mozilla might be good. There's 1% might be good to try to look at the wireless tests. That was the person who presented the ICCRG about the improved lower latency wireless paper. He has some relevant experience. If we can get him to look at it, that might be very useful.
Okay.
I assume he's talking about the AQM stuff from Tokyo, right? Yeah.
I can certainly check with him. Yes, and the last draft on the evaluation part is the video traffic model, and this one is also no known updates waiting from the author, so this one is also ready for review and should then be fairly close to working group last code.
From Jabber, Sergio Mena, one of the author of this draft, is saying he believes this is ready for working with last code.
And now you're talking about the video traffic model?
Video traffic model.
Okay.
There is a new version, I guess, pushed out.
Yes, it was updated since we had the interim.
Yeah.
So maybe we can have that one go along with the other two for working group last call if the working group is happy with that.
So one thing I was just going to say that we've implemented at least half of the traffic model in, I think, the trace-based one. We haven't done the synthetic codecs, but I think there was some rumor by Cisco that they were implemented in NS3. So if anyone's actually run that, would be good to see if someone's actually independently run the code base and gone through it and seen. But the results seemed good last time that we saw them.
Yes, we had some discussion about that at the virtual interim as well, where they were presenting the NS3, and I think some people were going to look at it, but I don't know if you have had time.
So as I said, like the second part of the draft we've implemented, so we're confident that it kind of works as we expect it to. The first one, it's not been independently been verified. So there's of course like results that we've seen, but no one's confirmed them. So it'd be nice if someone can confirm that.
Jahed, JavaScript. Sergio Mena again saying like they're working on getting the code ready for open source. What they want to mention, make sure is like it's a good quality code. So they're almost there. So the code might be getting open source pretty soon, so people can try. I think he's talking about, he's referring to this NS3 part. Because I believe this traffic model is already open source. I think so.
But it would be nice to get the LS3 because then we can satisfy.
Yeah. Yeah, he says in 3-4 weeks, you know, you get it.
Okay, yeah, so it would be very good, of course, if someone would like to try it out. And I think if once the code is available, that should also be a good opportunity for people to play with the different algorithms. Then we have some draft related to interfaces. We have the CC codec interaction, and we also have the individual framework draft. So we put this up for discussion later, how we should bring these documents forward and how we actually should structure the work around this, because we started with some documents, then the framework document was kind of asked for, but then we were working on the algorithms and the feedback. So this work kind of stalled a little bit, but now that the other things are moving out, we should revisit this and see, do we need to start with the framework document to have that and then see what we want to fill in, or do we need, what is actually the relationship between these documents, because this has been moving around a little bit. Then we have the work around the feedback, and that is also something that we have on the agenda there. So Colin will present an update on the feedback overhead, and then we have the associated feedback message draft that the design team has been working on.
And the feedback message draft is also on the agenda for AVT Core and Fred.
Yes. These are the milestones. So we are now, I think, going to be able to send out the drafts in July. So we are on track for the next few milestones. We, of course, updated the dates for these. So that's why we now are in track on those. And then at the discussion at the end, we will get back to the other milestones and how to approach the work around the evaluations of the algorithms now that we have the candidates, because our next milestones are several milestones related to that, actually. Okay, so next up is the feedback design team.
Zahid, do you want to say anything as introductory remarks? A sort of status update?
Hi. So I have a very short status update from this design team. What we have been doing. I think in interim we have been showing like we almost resolved all the issues we had. Only thing that was there was like whether we need a optimization in terms of compression or something else. There were some proposals, and during this interim and this meeting, the design team have been meeting several times. And what we have been doing, you have been analyzing and comparing like what is already deployed compared to what would be the RTCP bandwidth requirement if somebody deploys this this current format. And the idea was like if we can compare our numbers with the workable solution, and we have like certain margins to see like how efficient or non-efficient it is, we have an idea like, well, how much the compression would matter. And we have kind of come to a conclusion. I think Colin is going to present the comparison results from the design team that we have been looking at. And the current conclusion so far we have is like we don't see a great increase in decrease in our on the requirements on RTC bandwidth if we do some sort of optimization. So we believe from a design team point of view, this current format is pretty good. And after Colin's comparison, I think I'm going to ask whether we can conclude this work in Rmcat and move it to IETF Core for instance track. So I'll ask that question. So bear that in mind. After Colin's presentation, we're going to ask this question to the working group.
Okay, thank you, Zahid. Okay, so I'm Colin Perkins. I'm speaking from the floor mic, so not as a chair, as a design team member. I want to talk a little bit about the congestion feedback in RTCP and the overheads of the different congestion feedback schemes we have. So obviously when you work out, when you think about the overhead of sending congestion feedback in RTCP, there's a bunch of things it depends upon, right? It depends upon how often you want to send the feedback. It depends on what information you're feeding back, what type of feedback is needed, how you're formatting that information, whether it's being sent as a compound or a non-compound packet, how many media streams you're sending, and so on. We've got two approaches to sending this feedback, which I've considered. We've got the design team feedback, which is what I presented in, I think it's the Seoul meeting. I went through the details of that. And I also just did an analysis of the overheads of using the mechanism Google has been using, or one of the two mechanisms Google have been using in the Rmcat transport-wide congestion control extensions, which I think was presented here a year or two back. Yeah. Okay, so we looked at two scenarios. The first one is voice over IP. Second one is a two-party video conference. So beginning talking about the voice over IP, we've got a two-party VoIP call. So you have two SSRCs in the session, each participant sending and receiving audio, no video flows or anything like that. We're sending speech frames every TF seconds. Usually that will be every 20 milliseconds. And we want to send a congestion feedback every NR frames. And we can tune how often we want to send the congestion feedback based on how much overhead we're willing to accept and how quickly we want the feedback. As a result of that, you want a reporting interval, which is the framing interval times the number, how many frames you want, how often you want the feedback. And you can send the congestion feedback either in the regular compound RTCP packets along with the sender reports and the SDES, or you can use a non-compound packet and send it in between the regularly scheduled packets. And we're sending N sub NC non-compound packets between every compound packet. And we see that's a parameter in the analysis later. The format of the packet, which looking at the format Stefan has proposed, the format of the feedback packet looks like this. You'll see there's a fixed header with some SSRCs, base sequence numbers, packet counts, reference times, and so on. There's then a block of what's labeled as packet chunks, and then a block of what's labeled as received deltas. The packet chunks are either just a bit vector of, this packet was received, this one wasn't, or they're RLE encoded if you have long runs of received or lost. And the received deltas are just timestamp deltas relative to the reference time, and they can be either 1 or 2 bytes. Obviously, the size of this packet varies depending on how many other packets you're sending feedback upon, and it varies depending on the loss patterns, because you've got a loss RLE or a bitmap, and you can choose whether to send that as an RLE or a bitmap, and the overheads will vary. If you're only sending a single stream, this works. If you're sending multiple RTP streams, it's designed as what's called a transport-wide sequence number, so it relies on putting an additional sequence number in an RTP header extension, and they then send one feedback packet from one SSRC, which reports on those additional sequence numbers. And there are a bunch of issues about how that fits within RTP in general, which I'm not going to talk about. I'm just going to talk about the overheads. But for the voice over IP case, you don't need this header extension. You can just use the regular RTP sequence numbers. So what you end up sending with this system, what the Google implementation sends, as I understand it, you have compound packets which comprise the UDP, IP headers, a sender report, and a source description packet. If you use the, I forget what the RFC number is, the Rmcat recommended CNAME format, you end up with 18 octet CNAME, a sender report with a sender info block and one receiver report in it, and you end up with compound packets which are 108 bytes. Slide. You also send non-compound packets, which just have the congestion control feedback RTCP packet within a UDP packet. The size of all of this, of course, varies depending on what, the packet loss patterns and so on. I'm analyzing a couple of cases. If we start with the best case, which is that no packets are lost, therefore you can just put a single RLE chunk in, which says everything was received fine. And that takes up 2 bytes for the packet chunks. And the received deltas, the best case is that all of the deltas are small enough to, timestamp deltas are small enough to fit into 1 byte. Therefore, you need 1 byte per each packet you're reporting on. If you're reporting on NR packets, that means you have NR bytes for the deltas, and you've got 28 bytes for the UDP IP headers, 20 octets fixed header in here, and 2 bytes for the packet chunks. So you end up with the non-compound packets being 50 bytes plus NR, which is the number of reports.
Varun Singh from clarifying question. So the CC feedback's not sent with the compound packet.
The Google implementation doesn't, as far as I understand it, doesn't send it with the compound packets.
But they could.
But they could, yeah.
And for the analysis of both the proposals, do you send the CC feedback only with the non-compound?
Yeah, I'm doing the analysis this way with the CC feedback. For the Google proposal being sent only with the non-compound, the design team proposal, I'm sending it with the compounds as well.
Okay.
Yeah, just to match what, as I understand it, the Google implementation does. Yeah. And if I've got that wrong, I'm sure, I don't know if they're on the thing, but I'm sure Stefan will correct me by email if he's not on the meetup here. Okay, so you're sending some compound packets. Between them, you're sending some number of non-compound packets. You can work out the average RTCP packet size in a fairly straightforward way, plugging in the number of non-compound packets being sent just by averaging out size of the compound and non-compound packets. If you troll your way through RFC 3550, you find that the expression for the reporting interval reduces to the number of participants, number of SSRCs times the size of the RTCP packets divided by the RTCP bandwidth. You plug in the size of the average size of the packets based on the size of the compound and non-compound packets. You decide you want the RTCP reporting interval to be framing interval times number of packets you're reporting on. Do some algebra, and you end up with this expression for the RTCP bandwidth. And the Rmcat CC feedback draft walks through that in a bit more detail. And this is exactly the same thing as I presented at the Seoul meeting. I'm just going to be plugging in different numbers for the size of the compound and non-compound packets. So, if you take the Google proposal, Stefan's proposal, what this chart is showing is if you're sending, for example, audio where you're sending a packet every 20 milliseconds and you want to report on every second frame, then in order to do that, you need an RTCP bandwidth of 42.2 kilobits per second. Assuming this feedback format and assuming the best case where you've got the best case, the smallest feedback packets. As you increase the number of frames on which you're reporting, you report less often, then the RTCP bandwidth goes down. Similarly, if you're increasing the size of the packets, again, the RTCP bandwidth goes down. And in the best case, you can get down to 1.8 kilobits per second. This number, so ignore that number. But in the best case, you're sending 1 RTCP packet per second for 1.8 kilobits per second of RTCP. Which is a pretty good overhead.
So just confirming again, the 1.8 is when you're sending every 960 milliseconds or every 1 second of feedback, right?
It's when you're sending feedback every second. Yeah.
Right. Just to make sure that people understand, like
Yeah.
Those numbers need to be computed.
Yes, yes. So if you're sending, if you're using 60 milliseconds worth of audio in each packet, and you're reporting on sending an RTCP packet every 16th packet, which works out as once per second. And if you want to report faster, or if you want to have smaller packets and lower latency, then your overhead goes up. The faster you report, the more overhead you have. Perhaps obviously. Yeah. And yeah, I apologize, I missed updating some of these numbers, but the tables are right. Yes. You'll see these match the old table I presented in Seoul. I updated the slides and missed some. Yeah. So okay, if you go back one. So this is what you get if you're only sending compound packets. So this I'm not sure is quite right. If you go to the next slide, this actually matches the Google thing where you're alternating compound and non-compound, and the numbers come out as just fractionally less. Next one. Okay, you can do the same analysis for the design team proposal. The design team proposal sends compound packets with an extended report, and the extended report has the design team format for reporting on the timestamps and packet loss RLEs and the ECN feedback. And if you work through the analysis, and I had all the details of this in the presentation itself, you find that the size of these is 132 plus twice the number of reports. This one. Similarly, you can work through this for the non-compound packets, and it actually works out to be the same size. You do the analysis here. You come out with, it's doing exactly the same analysis. You come out with slightly bigger numbers. Go to the next one. And again, when you're alternating compound and non-compound, again, you come out with these numbers. So if you put all this together, what you see is that for voice over IP, the design team proposal comes out needing this much RTCP bandwidth. Stefan's proposal comes out with the yellow. And we see that the proposal that Stefan made beats the design team proposal in this case. Now, there's two caveats on that. One is that Stefan's proposal is not reporting on ECN feedback, whereas the design team proposal is. So we're sending more information, so we can expect us to have slightly higher overhead. The other is that I've made best case assumptions for the size of the packets. However, even if you make the worst case assumptions, and I did do this analysis, although I haven't put it on the slides, it still wins out, although not by as much. So for the voice over IP case, Stefan's proposal does win, but reports on slightly less information.
Stefan's proposal also requires the header extension and the media.
Not for this case, because there's only one stream.
Oh.
It does for the video conference case. So in this case, if you don't need the ECN feedback, then this shows that you can optimize things and get a win. And whether we use Stefan's proposal, whether we use something else, there's clearly a little bit of benefit in optimizing this. And yeah, in the most extreme case, you're going down from 2 kilobits to 1.4 kilobits of RTCP. It's a little more significant at the higher bandwidth cases. Okay, the other case we looked at was a video conference, point-to-point video conference, 2 participants, each one sending audio and video. So in this case, we've got 4 SSRCs, 2 for each participant, 1 for the audio, 1 for the video. We're assuming they're all bundled together into a single 5-tuple, so this is all a single RTP session. We're assuming a video framing interval of TF, so 1 over TF frames per second. We're trying to get the RTCP reporting interval to be some number of video frames. So the idea is you maybe want to send an RTCP report every video frame or every second frame or every 4th frame or something like that. And we fit in the audio reports along with the video reports. And again, we can send this as compound or non-compound. Okay, so quickly walk through the design team proposal, which we had last time, and then I'll go into what we got with Stefan's proposal. So for the design team proposal, we've got 2 SSRCs, therefore we need to aggregate the feedback into a single packet. We're assuming we're using the reporting groups extension to reduce the overheads of doing that. We're assuming we're using all of the various optimizations. You can have one SSRC as the designated reporting source and avoid having to send each of the reception quality reports twice. And there's a draft which is in the RFC editor queue that describes how to do that. And everything is aggregated, so it doesn't matter whether it's the audio or the video source, which is chosen as the reporting source. Next slide. The non-reporting source in this case ends up being an empty sender report because it's delegated it to the other SSRC, CNAME, and we report the grouping optimization header. And assuming an RFC 1722 style CNAME, you end up with 28 bytes for the SDS packet. The reporting source ends up as having a sender report with 2 report blocks, one for each of the audio and video SSRCs. It has an SDS packet with a CNAME and the reporting group identifier, and it has the XR block, which contains the congestion feedback. If you walk through the analysis, the size of the XR block is 2 bytes for each of the audio packets and 2 bytes for each of the video packets it's reporting on, plus a fixed header. And you do the sums and you come out with 156 bytes plus twice the number of audio packets plus twice the number of video packets for the size of the compound. Plug that in along with the size of the UDP packet, the non-reporting SSRC packet, and you end up with 252 bytes plus all of that. And because you're aggregating 2 SSRCs into one packet, you end up halving it, and Magnus had the draft which describes all of that. Okay, we're then making a couple of assumptions. We're assuming everything is constant rate video because otherwise the analysis is not practical. We're assuming all the frames are equal size, so we're just chopping up the bit rate into equal size packets. Audio is assumed at being sent at 50 packets per second, 1500 byte video packets. Same RTCP calculation as for the voice case, you just plug in different numbers for the sizes of the compound and the non-compound packets. Okay, and what you get, and this is a little tricky to see what this slide means. I've worked with a set of different media rates. So we've got the media bandwidth on the left, and a set of different frame rates, and that gives you number of audio and video packets that you're reporting on. So if you're assuming 100 kilobit per second video and 8 frames per second, that works out as 1 video packet and 6 audio packets per report. And you need an RTCP bandwidth of 33 kilobits, which is a third of your media rate. If, for example, you pick 1 megabit per second, 30 frames per second video, you end up with 3 video packets per report, 2 audio packets, and need 122 kilobits per second of RTCP, which is 12% of the media rate. So that's working through a bunch of different media rates, a bunch of different frame rates. And we're only sending compound packets here. We're not filling in with non-compound packets. And you see the overheads vary from about 35% down to about 6%. You can also send reduced size packets, and this lets you omit some of the details. Just send the feedback and so on. If you skip on the next slide. If you do that, you find you reduce the reporting overheads from, these are about 30-35%, down to 20-25%, and this goes down to about 4%. So you get a win by sending non-compound packets in between, as you would expect, because there's less header overheads. Okay, next one. Okay, am I going the right way? Oh, keep going. Okay. Right. Okay, let's go back a couple and losing track of where I am. The colors are disappearing. Go back. Okay, so this, am I doing this right? sure I've done this quite right. Anyway, let's keep going. Yeah, a little lost. Yep. So this I think is looking at the, if I remember right, it's looking at the Google proposal, and it's trying to work out the overheads of putting the compound packets in for the audio and the video for the Google proposal, which is just a straightforward sender reports, reporting group extensions, and so on, which would be the most optimal way of doing it. If I understand right, this is not quite what the Google implementation does. I think they do something slightly different, but I think this is actually lower overhead than what they're doing, and it matches what the design team proposal is to do for the compound packets. If you get to the next one, and you end up with 220 bytes, and you halve it because of the aggregation. The Google proposal also for that sends non-compound packets. So the compound packets are just regular packets, and they then send non-compound packets that have the congestion control feedback in them, and that's the only congestion control feedback it sends. The non-compound packets here, we're assuming, again, if we start with assuming the best case, there's no packet loss, the deltas will fit into 1 byte. You end up with the non-compound congestion feedback packets being 50 bytes header plus the number of audio packets plus the number of video packets you're reporting in the best case. And that's the NA and the NV come from the receive timestamp deltas, and then it's a 48 bytes header plus 2 bytes for the loss error. And it sends a single feedback packet which reports on all of the SSRCs. So you put those numbers in with the Google proposal, and you come out with these RTCP bandwidth requirements. And again, we're assuming the best case timings, and we're currently excluding the overheads of the required RTP header extension. Next slide. If you assume the worst case, so the worst case, we're assuming the packet loss is unpredictable, so you need to send a bit vector rather than the RLEs, and we're assuming the timing variation is large enough that you need 2 bytes per packet for each one. So that's the best case and the worst case. You come out with a slightly different expression. You need to round up. You take the number of audio video packets, divide by 7, because you can fit 7 into each 2 byte chunk, round that up for the worst case, twice the number of audio video packets for the received deltas. Next slide. And you plug the numbers in, and you come out with, as you would expect, slightly higher overheads. Okay. So to compare them all, if you just look at the RTCP overhead, the design team proposal comes out with the blue column. The Google proposal comes out between these 2 yellow columns, depending if you make best or worst case assumptions. And looking at this, it looks like the Google proposal wins out. Next slide. However, the Google proposal also needs an RTP header extension, because it needs this transport wide sequence number. And that takes up 8 bytes per packet for the header extension. If you include the overhead of that header extension, and you add it in, you see this result coming out. And what we actually end up with is that the design team proposal slightly wins out in most, but not quite all cases. And it all depends on exactly how many RTP packets are in each report, and et cetera, et cetera. But we do end up with a general slight win for the design team proposal in this case. So, what we've done here is compare the performance of the 2 approaches to sending feedback, the design team proposal and the Google proposal. For the voice over IP case, Stefan's proposal, the Google proposal wins out, provided you don't need ECN feedback, because it doesn't send ECN feedback. For video, once you take into account the extra cost of the RTP header extension it requires, Stefan's proposal loses slightly in most cases to the design team proposal, although there are a couple of cases where it wins out. the bandwidth, the RTCP bandwidth for the video, especially for Stefan's proposal, is very dependent on the data rates, packet loss patterns, exactly how many packets are reported in each case. So you find some cases where it wins out, some cases where it doesn't. The design team proposal also has the advantage that it conveys ECN feedback, whereas Stefan's proposal doesn't, and it's more compatible with the way RTP uses SSRCs. So I think my conclusion is that, in general, given that I think we're mostly interested in the video conferencing and the more we want to be flexible and support a wide range of scenarios, I think the design team proposal is the right way to go, especially if we want to include ECN. Although if we do care about highly optimizing the voice over IP case and don't care about ECN, we can clearly get a win by optimizing things differently.
John Max, and I think the design team feedback also, if anybody ever comes up with a multi-point congestion control algorithm, would extend to that naturally, right?
Yeah, definitely. And I have to say, one thing I haven't done is simulated for example, 15-person conference and see what the overheads are there. So there's a bunch of scenarios we haven't looked at here, but for the two simple cases the design team has been considering. I mean, one of the things we had in the Seoul meeting is that there are other savings you can make. I mean, this is making assumptions that you're sending 18 bytes, so 16-byte R group identifiers and 16-byte CNAMEs and that sort of thing. And you can certainly send smaller identifiers in some of those cases, and you can get wins in that way. And you can play with the number of non-compound versus compound packets and that sort of thing. So there are other optimizations you can make. Okay, that's all I have.
Any more questions or comments? No, Said, you want to get back to your question?
Yeah, Jahid again. So as I was saying in the beginning, I mean, from design team point of view, we have been doing discussions around it. We have been looking at other factors that has been proposed, like hourly and compression and separate ECN vector. And also we now have compared this with a deployed solution with some of the numbers that Colin mentioned might not be as exactly as how deployed, but I think we have included the numbers. That's not like it's a bit bigger than what is there. But still, I mean, I think we have done we have seen this comparison, and our conclusion was like, well, there could be optimization, as Colin mentioned, like if you don't think of little bit of information or is information, but we didn't feel like it's worth doing the optimization. So the question is like, are you guys also agreeing with the working group, agreeing with that conclusion? And if yes, then the next phase will be moving it to AVD core as a DT Rmcat AVD core draft and asking for a further proceedings of this draft. So any comments on that one? And I also heard like somebody has implemented this thing at it works for interoperability. That's like good to hear. But any comments?
Varun Singh. So I had a question. Given that could you go back to the VoIP scenario where you compare the two proposals?
VoIP scenario, right?
Yeah. So the reason I bring it up is to see, because that's the scenario which is where we can be the most optimal, right? And if the savings are not in the congestion feedback, because I can see it's about 20% off, right? So like the yellow is 20% lower than the blue. Now the question is, do we want to make some savings?
You mean
like do we want to engineer some more to make the 20% savings? And if it's not in the feedback message, then where could we gain the 20%? Because in the video scenario, they're off by, they're not off by much. So you can't engineer much in that scenario. But I see why people would care about the audio only scenario and want to optimize that, because you have only one stream, and the proposal is like the numbers are close, 2.7 compared to 3.5, but if you put them into the algebra, it's about 10 to 20% off. Now, the question I have is, does anyone care about the 20% lower? And if people don't care about it, then your question's worthwhile. Like, we should move on. But if people feel that we want to make the 20% saving, the question is, where can we make because it's not in the feedback format as far as I understand.
I think Colin's going to reply to that.
Hi, Colin Perkins from the Floor Mic. I think partly the difference is the feedback. I mean, one is reporting on ECN and one isn't, although that certainly doesn't account for 20%, but there is a difference there.
Yeah.
I think also partly it's that one is sending feedback in every packet and one is sending it only in the compound packets. That will make a difference.
Yeah, I think so.
We're also slightly formatting the things slightly differently. One uses an XR block and one uses a regular RTCP packet type and so on. So the slight differences in header overheads. I think a combination of those things is probably what accounts for pretty much all of the overheads.
Yeah, I think you can play with the numbers and actually get close to this. As Amber, you mentioned, like it is not in the feedback message, it's something else.
Right.
So you can in deployment you can try to see like where it comes from. And I think in the other previous meetings, Colin also showed that it's the header thing that's actually bothering us more than the feedback. Actually, the whole RTCP header thing.
Right. So the 1.4 that I see here is the non-compound version, and the 2.0 is compound and non-compound, right?
Yeah. So it's a bit.
It's apple and oranges, but we know the.
But this is like compound. I mean, you can. I think you can play with this non-compound compound combination. You can get like pretty close figures here as well. But we want to. I think the Colin's point. I want to show that like this is the case might be there, and this is not that far off.
So my question was just to confirm that people understand that the 20% is there, and if they are willing to live with it.
Yeah, I mean, we can do things like changing the XR block into a regular RTCP packet for reports, for example, and save like 4 bytes or something, which probably accounts for most of the overheads.
Sure.
Yeah.
So, Jonathan Lennox again, sorry. This is, I'm just trying to make sure, so you're doing a VoIP call where you're sending a compound packet every other voice frame, essentially?
No.
So how often are you sending compound in your case?
So
Every sample.
So it's 2 plus 2.
So in the so hopefully the microphone can pick me up. So in
Yeah, to pick it up, it's removable.
Yeah, okay. So in this bottom case, for example, with every 16 packets, we're sending. I think we're alternating compound and non-compound packets.
That's still sending a compound packet. I mean, I assume in the Google case they are sending compound packets sometimes, right?
Yeah.
Which you didn't count at all here?
If I did it right, they're included.
Okay, because I mean,
someone should check all my.
Yeah, because I mean, because presumably, they feel like it's further, they don't need to send compound packets more than every whatever interval they're doing. So then presumably they're not pulling that completely out of nowhere. So
no, sure.
Yeah.
And
it just feels to me like you're sending compound packets more frequently than you need to, which hurts your numbers here.
Yeah, it would definitely, yes. Yeah.
So if I remember these slides correctly, the yellow number is actually the better number for Google's case, and that's actually only the non-compound, if I remember correctly.
Right. Yeah.
Because the other number is 1.8. at the lowest one. So
So, yes, and one thing we do need to do is this was my calculation. I think nobody other than me has checked it, so we need to check that I've done this correctly.
So, I mean, I'm not hearing like people are super sad about this, but what I am hearing, like we can do engineering around it to actually make the difference. And these figures are the slide. What we're looking at is not even the same kind of values. We have like alternative reduced compound, and we have only reduced size there. So, Vernon, you have more?
yeah, I was just going to ask, are we going to document, so just going back to what Jonathan said before, are we going to document strategies on, because you could do a lot more savings by not doing, just doing non-compound or dithering the compound packets further apart and putting more non-compound. Because once this draft moves to AVT core, I guess it would need to come back once in a while to be discussed here. But some of these strategies might impact congestion control algorithms. So before we give AVT core the thing, do we want to document like what the instructions from the candidate algorithms are for?
Yeah, I think in design team we discussed this actually,
Okay.
and we decided like, okay, we can have a guideline for how to use this. I mean, there are other things that was on the discussion, like adaptiveness of RTCP, feedback, and all these things. And so the decision was like, okay, we'll have the packet format. The design team will be there. We'll be producing this as a just and packet format, and go to the AVT and publish it. And then if design team continues doing this adaptive thing or the guideline thing, design team can produce another document.
So that's a separate document?
Yeah, that's a separate document, I guess. Because otherwise it will be overcomplicated and it's not going further then, because those are the more complicated thing, and that people need to agree and do some more experiments. So I believe it's better to be a separate thing than this one.
So Magnus Westland, I haven't participated in the design team, but I mean, from my perspective, I don't see those bitrate differences that significant. And I mean, you can tweak more, I think, in the space we've been talking about, how often you send compound, etc. There are, I think, but the important thing here is, I think, is to have a structure which aligns with RTCP as normal RTCP use. So any future extensions in other dimensions also be able to hook onto your on those non-compound packets, etc. when you need it, etc. And so I would expect that when you write this as a packet extension, you actually need to, in AVT core, you probably need to at least discuss a bit of where it's transmitted, etc. and because of its intended use. So I think you're going to get to go into part of discussion, maybe just on guidelines level, but about how you use it for being reasonably efficient. So.
Agnes said what I wanted to say.
Hi, Colin Perkins from Flowmac. So, I mean, we have the Rmcat CC feedback draft,
yes.
Which currently just works through this analysis, or an earlier version of this analysis. In some ways, I think it would probably make sense to put the discussion about how you tune TCP and how you use the packet format into that draft rather than into the draft that just documents the format, especially since that's an Rmcat and the other one will like draft and the other one will likely end up as an AVT draft.
I think that makes complete sense to me. I mean, this that draft is supposed to be having requirements or like behavior of Rmcat feedback. So that makes complete sense.
Jonathan, I mean, the one pushback I might make on that is, the problem is it's not how much you tune it as, because the algorithm and the feedback happen at the opposite endpoints. If an algorithm needs something specific about the feedback, it's going to need to be negotiated. So, and I think that might need to be in the AVT draft. That's going to specify whatever, signaling negotiation you have to do along with this message. I would imagine.
Colin Perkins, too far to walk to the floor mic.
Okay,
But,
I'll make that mic closer to you. You're a little hot.
sorry, Colin Perkins, too far to walk to the floor mic, but from the virtual floor mic. I don't believe this needs any additional. Well, I think the only additional signaling this will need will be one to say use this feedback type. Everything else is just the existing tuning knobs we have in SDP. Things like tuning the RTCP bandwidth fraction and enabling different features which already have signaling extensions.
All right. I mean, I guess it's a little indirect is my worry, and somewhere you're gonna need to say, you know, if I give you this RTCP feedback fraction, I intend you to use the whole thing, and things like that.
We need to give that guidance.
Yeah.
So just going back, in the end, there's a sequence number that you report on. I don't think there's a way to say that you report on fewer sequence numbers or faster anywhere in the mechanism. I think you just live with whatever the other endpoints actually. So it's the sender decides to report on whatever it's receiving. Yeah, the feedback sender decides whatever. So then the congestion control just needs to adapt to. If it's reporting on the 16 thing on the 16 frames and you want it to report on 4, I don't think there's much the media sender can influence on the report sender.
So then my question to the chairs, like, shall we take a hum on like agreeing on like we're done with this and we want to move forward to AVT core for further processing of this draft, or?
Yeah, we can do that. My impression is that we have some discussion, but most people seem okay with the proposal. But to formalize it, let's take a hum on it. So if you are in, the question is going to be if you're in favor to move the document forward to AVT core, then it's a yes for the first hum, and then if you're against moving it forward in the second hum. So first, if you are in favor of moving the document forward to AVT core, please hum now. And for the record, that was a pretty good support in hum. And if you have objections for moving the document forward to AVT core and have concerns about it, then please hum now. Okay, and there was no hums against, so I think we're ready to move it. Okay. Thank you.
So I think that's it. I think then I think the working will also have to decide whether the design team still will work on some of the other things that we discussed, like guidance and all these things. But I think in AVT core it will be again pursued as a Rmcat design team point of view, right? So with the Rmcat design team, will again have to do some revisions and to incorporate AVT core things.
Yeah, I think, depending on the feedback that is received,
yeah,
the design team will be the recipient of that feedback in Rmcat, I guess. So,
but how do we do? One question I'm really don't know answer. Like, how do you do? We keep the draft in Rmcat and have discussion on AVT core, or do we submit another draft in AVT core? How are we going to do it?
Currently this is an individual draft.
Yeah, currently this is an individual submission. So, it's on the agenda for AVT core on Friday, and AVT core will decide, I think, if it wants to adopt this as a milestone. And, we're obviously, we can say we'll use the fact that it's currently named draft DT Rmcat does not stop AVT core from saying this will be the basis for draft AVT core feedback message or whatever.
Yeah.
If it wants to. So, we'll take that up in AVT core.
Okay.
And my assumption as working group chair is that we will be last calling this in both working groups.
I would expect so. Yeah.
Assuming it's adopted.
Yeah.
Okay. Then, thanks.
okay, thank you very much to the whole design team for all the work on the feedback, and very good that is progressing. Say it. Say it. You forgot.
Yeah.
Okay. Then we will move on to the last point on the agenda and the discussions on the outstanding parts of our milestones. So first we would like to revisit the work on the interactions between the applications and the RPP flows. So some of this started quite early, and there were some different documents circulated, also some of this before the current chairs were active. And we have a number of related drafts. So there is the Rmcat CC codec interaction draft, which expired some time ago. We have the framework draft, which is an individual draft still at the moment, but that came about as a request from the working group, and then an even older draft on Rmcat app interaction. So we would like to ask the working group how you think we should, what documents do we actually need here, and in what order do we need to produce them, because this discussion has been kind of going for a...
So I'll start with the last one, because I think the last one got split into CC codec interaction, and the other idea was to keep some part of the app interaction there. I'm not sure if it's been overtaken by events, because I think 2 years have passed in between, and like whatever recommendation Rmcat had wanted to make for the app interactions probably already been done. I don't know if you want to document that still in the interaction between the application and the congestion control. And then the CC codec interaction was the lower bit. So we had a document which was all inclusive. We split it into 2 parts. The app interaction, of course, because most of that guidance had to go to W3C. We worked on some of that and made that happen. So there's some set parameters, get parameters that the application can do. The question is, do we still want to document that bit here in a simple document, or just say that it's done somewhere else?
So you're saying that the first question really is this still useful or not?
Yep.
Any opinions on this?
I think, Jahed, I think the framework document kind of like try to create a ground where the other draft can see like things are happening, but by doing that, it almost explicitly or implicitly says like what kind of app interaction you're trying to do. I don't know, like it's a bit interesting if I say that, like if app interaction framework document should have all these kind of things again, because that was where we started, like in the beginning, saying like, well, we have one document doing all the interaction thing, and then we split it up. But I do believe framework document has a other purpose. So basically, we have 3 kind of experimental, as I believe, 3 kind of experimental condition control algorithm will be there, and we need some sort of framework to actually see how implementers can use those things. So framework document definitely serves another purpose, but I don't know, like, will it be good to just say something about app interaction or CC interaction? Because there are like modules, like where this is an app, and then they talk about, and the idea was like when a framework will have the modules of codec and app, then app and CC and app interaction will come and say like, this is how we interact with this framework. Maybe that's it. Maybe we want to work with framework document and see like how much we need to put in the other interaction documents. That might be one approach. Like, let's work on this framework document and come back to the other interactions when we have a bit clear idea what kind of. And if the working group really thinks like it is covered on framework, then we can skip on it.
Actually, I have something about framework, but I'll wait for Julia to speak.
Me, Kulivin, just one comment. So the reason why we split it up is because it's really for a different audience. Like the framework is for somebody who wants to work on congestion control mechanisms. The codec interaction is for somebody who wants to work on codecs. And the app interaction was like for app developers, for like external people. So, but if like the feedback is already where it needs to be, we don't necessarily have to push it to an RFC.
Okay, so now I'm going back to the framework thing, because I believe the framework work started And I think when it started, the idea was for the framework to be adopted by the individual documents that propose the congestion control. And that never happened. And we're last calling all the documents without actually any conformance to the framework. Now, so in some sense, the framework then actually makes claims or like decides guidelines on things that have not been adopted by the congestion control algorithms. And that's an interesting question, because now we're in a chicken and egg problem, because the framework is there, but no one's actually used it in that exact way. So again, since it's not been used, it's the veracity of the claims made in the document are unsubstantiated.
Yeah, Kulevin, and the reason why this didn't happen is because we didn't want to hold the work up any further, right? So I would, as an individual contributor, I would argue for if the group decides to move more than one mechanism forward to propose standards, to also take up the framework document again and make sure that those documents align then.
Yeah, so this clearly is an opportunity, right, for the next steps that we need to take. If we now have 3 candidates, and if we now are going to move them to, we don't know the outcome of that process yet, if there will be one, if there will be multiple, or how the evaluations turns out. But if there will be multiple, then it could clearly have a benefit to have some common terminology for the algorithms that we propose.
Yeah, I think Maria said what I think we discussed it a bit in around the authors and also with the chairs, like what is the future of this framework if everybody is already going forward with the congestion control. And the idea was like, okay, when it's like going for a standard track, if it happens, this document would really, the final output of Rmcat will conform with this framework. So there is a point of actually working with the framework. I think the framework didn't get adopted last time we presented. I'm now talking as the author of the framework. One of the author of the framework document is like there was some terminology, RTP terminology that was brought by Varun, I guess. But we actually communicated with Varun, and and also in the mailing list, like if anybody has any kind of idea how to solve those issues, we didn't get any, like, I don't think we get any responses on that one. So I mean, from an author point of view, as we are putting our time on it, and it is an outcome of what working group wanted us to do, I would further think, like, if you want to work on it, adopt this document in the next update. Perhaps we work with the issues, update it, and then work on it. So otherwise, I mean, it will lay around as an individual, and then we spend quite a lot of time on fixing all these things, and then might be of no use.
Yeah, so this is one reason we wanted to bring it up here, right? So that we can see what path we think we should take. Because I mean, we have an option to now say we have 3 candidates. Now is a good time to work on the framework and see that we agree on terminology. And yeah, whether the other documents are still needed or not. I mean, I think we need someone that find them useful. Otherwise, we should.
So
not
the first
spend
one is the most mature of it. So I think we just like need to figure out what's missing from that, and maybe even get a round of reviews. I think it was quite ready when the 01 and the 02 were submitted. So I think the first one should move on. The only thing I'm concerned about the framework is that since the 3 documents don't take the terminology or not conformant to framework, I have this feeling that it might be overtaken by events again. Like you would have a framework document, which probably defines everything in a nice way, and then maybe the burden is for the new algorithms that may be proposed later on for experimental. That might be guidance to them to use the framework document, because so that I feel there's work for framework to be done. I'm just afraid that we'll get this thing done and then maybe it'll be overtaken by events and no one's actually going to ever use them.
I guess the other question would be whether we should be doing it now or whether we should wait a while till we've got more experience with the candidates and do all of this work, in a year or so's time, maybe when we're thinking about, okay, which candidate should we bring to proposed?
So the document's already there. I think there's nothing stopping them, stopping the authors from review, like updating it based on practical experience.
Yeah, sure. I mean, the question is, do we just keep it, bumbling along for a while and while we get some experience, or do we try and finish it now?
That's a good question. Like, I think the question is if you're ready to finish it now, then why wouldn't the documents that are already just going out, like, why wouldn't they make a comment on the framework?
I think, it will take some work to finish it up, of course, and we will need to have the agreement between the candidate algorithm authors that this makes sense for the algorithms. So, certainly it's not ready at this point. It is work that would need to be done.
Sure, and I understand the overlap between the authors of the proposed algorithms and the framework document. So, assuming they can't work on both of them simultaneously, they probably prefer to work on the algorithms themselves and like taking them to completion. But that's what it's an energy question. It's like if these documents do not need it, then who are we writing it for?
Well, I think that if we are going to push multiple, in the end, if we were going to push multiple algorithms for a proposed standard, then using common set of terminology for the same things would be required, right? Now they are all experimental and in some sense not so aligned, but if we're going to push multiple documents, then I think you could see there is a value for having them consistent.
So that was just my concern, and I just want to voice it. So
yeah, but at this point we don't know the outcome of that process. So that could be an argument for saying that we keep it around, we can update it, but we don't put the effort on completing that now. When we know more what we think will happen with the candidate algorithms and what to push forward, we also see more what we need in terms of aligning the terminology and the framework for the documents. Regarding the codec interactions, I understood that this was also held up because it should relate to the framework, right? Wasn't this why this work at some point, at least in the discussion, why that stopped? That is at least...
No, I don't think so. They were like, the framework came much later. I think it was the app it was full app interaction, app codec interaction or something like that it was called before. It got split into two documents. All the app stuff got removed from the original document and only the CC codec was kept. I actually do not have any recollection with the framework. Maybe Zahid can, since he's the common author between the two, if he can.
Clearly the other document is older, but the CC codec interaction has not been updated for a while, and I think that was because it was decided to have the framework document, and the relationship between the two were kind of keeping the other one on hold as well.
I think there has been long-standing history behind these documents, especially the codec interaction, app interaction. As far as I remember, the codec interaction was pretty ready, but then again, what you said, Anna, like we started to work with Rmcat framework document, and we would like to. The app interaction, codec interaction doesn't mean. They would like to interact with the framework, so. And the idea was like we should use a common terminology and stuff like that. That was the only thing I remember actually. That, but I don't know. Like I thought like the codec interaction didn't. It's expired because of lack of enthusiasm from the working group to work with it. That was my thinking. But yeah, it was. There was discussions like okay, having that interaction and having the interaction with the framework makes a lot of sense. So let's work on the framework because at that time it was an urgency from the working group to work on the framework document. Like let's work on it and align the other and the proponents to the framework document. But then the working group realized like it will be a longer process to actually finalize the framework document. So we said like for sake of progress, we don't hold up the proponent algorithms just because of the framework document. We move on, and that's why we didn't really work a bit more with framework document. So this is the story in short. So which is holding up what it does. To me, it doesn't really make sense now. It's like now it's actually the working group need to decide again what we're going to do with this. So it doesn't really matter which is holding up what now.
So, I mean, do people in the group see benefits in finishing these 3 drafts, or have some of them just become obsolete by now?
I think the CC codec one was always important because it actually says what the CC and the codec would do, like are you going to increase and decrease? And that's why I think the reliance on the framework is only between those components in the framework. We can of course go back and look at the framework. I haven't had to look at the framework document recently, so I can't really say if it touches more than one component or more than the 2 components that are named in the title. But it would be worthwhile to check it out. Maybe Zahid and I can take some time offline this week and actually come back with what we think maybe the next steps for this.
Jahad again. Yeah, I personally don't believe there is a huge mismatch or need a huge amount of work to actually align the codec interaction, the current framework document. But the thing is, like, we're not working none of them. That's the whole point. I think that we're discussing whether it's needed. If needed, shall we be again resurrecting these drafts and start working, and maybe from the very beginning. And I don't believe like all the 3 and the framework, it needs huge amount of work to just align. As I was a common author, I know like codec interaction and framework. It was like we have been thinking about like this alignment from the beginning.
I think I remember why we might have stopped it, and that might have been the FEC thing, because that might have been one of the things that the CC codec says, that when you have to increase the bit rate, you might want to do it opportunistically or something, and then it probably interacts more with something like an FEC thing as an extra component, which perhaps the framework wants to like have some ideas about. Right. So maybe the point we can take is that maybe Zahid and I and some other folks who are interested in this can actually sit down sometime this week and come back with what we think, and then maybe if there's other people who have opinions, we can get those.
Yeah, I mean, if some of you are willing to look at these and come up with a concrete proposal for what to do going forward, that seems reasonable. Obviously, if there's no one willing to do the work in progressing these, then we're not going to go anywhere with them if people don't see the need enough to do some work. But if you're willing to work on them, sure, and still feel there's a need for them, then yeah, sure, that's.
Jahad again, maybe we can ask this question. Like, there are a couple of implementers here. I see, like, they're working with some sort of implementation of this. They can actually say like whether this kind of document is useful for them for implementing already proponent. So that would make quite a lot of sense to me actually to start working on these things. So anybody implementing this condition control algorithm, just come to Mike and say like what they're thinking. I think.
Me, actually not an implementer, but I also don't think that's very useful because people have an implementation already. So just adopting it to something is just overhead. I think this document is really useful for open the floor to make it easier to develop new mechanisms.
I also think where we really need this is if, as we've said earlier, if we take multiple drafts to propose standard, we need to align terminology and so on. So that's where I think this is going to become more critical.
What I'm saying again, since no one's saying that we don't need them, I think we have a way forward. Since no one's saying we don't need it, we probably need it. And since we think that we probably need it, we probably should keep the drafts and like keep working on it. And we can figure out what the actual outcome, if it's going to happen this year or I don't know if March 2018, if we're looking at a more forward-looking, like if this is going to be guidance for picking something for proposed standard, then maybe you should move the dates further.
Yeah, the dates clearly may need some adjustment. But I think the main question we had was if this is a work that we should push forward now, or if it's something that we should, put on hold for later, or what the feeling from the working group was from the need. But I mean, if, as Colin said, if people are willing to work on it and see that it's useful, then still, it's not so many people involved in the discussion. So in that sense, if the ones that are interested want to have a further discussion on it and come back on the mailing list with how you would suggest for these documents, I think that would be useful, and then we can have a further discussion on it. And I think for the implementers, if you have implemented it, it's true that aligning would be an overhead, but it could still be interesting to know if you feel that something like this would have been useful when you implemented it, to kind of see, because that kind of relates to further implementations in the future, right? Okay, anyone that wants to add anything on this topic? Okay, then we move on to the second discussion item we wanted to bring up in terms of how to move the work in the working group forward. And this is, we now have a number of candidate algorithms that we are pushing out as experimental. And the next steps for those algorithms, of course, is to have evaluations and see if some of them are suitable to be pushed forward as for standards track. And as a working group, we need to kind of agree on what type of evaluations and how we should follow up on this work. So that is the point that we would like to have some input from the working group on, what you see there. We have a number of starting points that can play a role in this. Of course, we have the evaluation drafts, and we can go back and check against those at some point. Each of the candidate algorithms are identifying aspects that should be evaluating during the experimental stage part. And of course, in some sense, we also need to look back at that and see how that turns out. We will need some deployment experience from the algorithms. And we also have the NS3 open source module that was discussed at the interim that could also allow experimenting in a controlled environment with all the algorithms possibly.
So in my opinion, I think the last one, the NS3 Rmcat or open source module, is basically for taking things from a draft or an idea to experimental. I think most of the candidate algorithms have done something similar, either like in a benchmark test bed or inside NS3 or NS2. So I would definitely remove the last one, because I think that's what we used for the first round of evaluation. I think there are a lot of papers being published for some of these things, so that's also another. So I think both Scream, NADA, and GCC have had some track record on that end. I guess so. The first draft of evaluation results, is that like just pointers to results, because people have been presenting their results and some of them have been doing it in some form of test beds and so on and so forth. So I'm curious what the working group thinks the first thing is, and like what would trigger the second bullet.
So I think that's the discussion we want to have. I mean, some of this can clearly be, or could clearly be, formalized evaluations using a set of criteria we've come up with. Some of it could just be reports on deployments and real-world experimentation. And I think the discussion we're trying to have is to what extent we need a formalized criteria for this, and to what extent we'd say, okay, come back in a couple of years when you've got some experience with some documentation of that experience, and then we'll have a discussion.
Yeah, cool event. So at this point, I would really like to see some results from using it like in the wild on the internet, not only in a test bed. And the point about having a draft about this and publishing the draft is also to give then, when everything is finalized, give people some kind of additional documentation about which candidate is the right one to choose. And that definitely needs also to relate to like real world experience and not only test bed.
And I think also one thing that would be still interesting is comparisons between the algorithms, because I think a lot of the results are still being done individually for each algorithm, and even if the test scenarios are specified, there may be some differences, so it's not always easy to compare those results. So I think there is also still room for actually comparing all the three, and maybe also with the common feedback format, and so that is still a space, right?
Right. So just getting back to this, so we've done, out of the 3 algorithms, we've done 2 with varying levels of success on this. And so I think the thing that I want to like push a little bit more on is like figuring out what the wild means, because it might be too high a bar for some people. If we like setting the bar for what we mean by wild is actually an interesting point to make, because I think media said like testing it in the wild and setting the bar on what we mean by wild is like an interesting discussion. I think that's more interesting than because if you set the bar too high, then some people might not be able to meet it, and if you set the bar too low, like then we don't have a comparable results.
Jahaz is grabbing from the Java room. Sergio Mena, it would still be useful to compare the algorithms with the same simulated environment. Yes, that's where NS3 Rmcat is useful. I think he meant NS3 Rmcat implementation, this test case implementation, perhaps.
So we have Randall in the queue. So Randall, you're up.
Yeah, Randall Jessup, Mozilla. I agree that having the same environment to test them in is a useful double check, but I also agree with Maria that we should definitely be trying these in the wild, and Mozilla is willing to help try to integrate some of these so that they can be tried in either in private builds with Firefox in the wild. Potentially, if they're stable enough and such, it could even be made something that could be flipped on and off dynamically in regular builds. But that'd be a second step. But certainly, we're willing to work to let that be used for actual video calls and for this.
Yeah, so before you go away, probably you can also help with like what are the right metrics to measure this stuff, right? Figure out that everything went right.
Yeah, getting it in is the first step, and make sure it works. And the second step is then once you have it in, how do you then evaluate how well it's working in the real world, which is not necessarily a particularly easy thing to do beyond simple subjective comparison. Perhaps something whereby yeah, that's an interesting area of discussion. So yes.
Yep. I had a different comment. I wanted to say I think the bar for getting a document or an experimental RFC, getting something documented in an experimental RFC shouldn't be too high. But to get it to proposed standard, we can actually set the bar rather higher because there is already documentation. People can try and work with it, and kind of moving it to proposed standard is really saying kind of we're sure that this is something that works well and we can recommend you to use it.
So Varun Singh, and this time I'm going to probably use callstats.io, and so not only as an individual, but as a company that measures things, I think we can definitely help in this. So if Mozilla or Firefox or any other browser would develop builds that could be put in the wild, we could definitely help build an app which could measure, and we have ways to do that. And like, of course, the question of subjective quality is an interesting one, and I think that we can look at as we move forward. But this is something that we could really help with, given that we have large-scale instrumentations of apps and so on and so forth. So if there would be a way to control this from the application, to choose a congestion control or whatever mechanism the browser vendors can come up with, we'd definitely be able to help with the evaluation.
Okay, thank you. Colin Perkins from the Flomec. And one of the other things I think we need to make sure we take into account when we do all this evaluation is making sure that the candidates have converged on a feedback format, and that the feedback formats are working for them, which is something we haven't done any evaluation of so far. Yeah, we've designed a feedback format, but I don't think the candidates have done experiments using it.
Jahed, I'd like to thank Mozilla and callstats.io for saying that they are willing to help. And for your information, we have, for Scream, I'm talking now about Scream, we have open source code. So it would be, I think, very interesting to see, like, if somebody use that one, integrates that one, and try it in the wild. And yes, I would like to second what Colin said. Maybe the implementation I think not maybe, it need to use the feedback format we are trying to see like if that is also working. But yeah, I mean, we're talking about setting bar for from experimental to standard. We're talking about setting some high bar or low bar or mediocre bar to do that. I think getting from experiment to standard is the biggest step. I think we should really be careful about it. But I don't think, like, when we're talking about setting bar, we're talking number of user and all this thing. It's just like we would like to see some users in the wild and see, like, it's working, it's not melting the whole internet down. Or, I mean, I heard, like, we're setting some bar, but I'm not hearing the discussion of, like, how we're going to setting the bar. So what are the things? Yeah.
I don't think that the discussion, the discussion of setting a bar is useful right now. Would probably be good to see some first results, and then rather have a discussion about what's the right metrics to track, and then you can actually say this is ready or not ready. I don't think you can make a decision on this right now.
Yes, it's certainly very positive that we have a number of people that are willing to work on trying out the algorithms. And a first step is, of course, to collect results and experience with the algorithms in various forms.
So I had another question, which was, so I think a few years ago we presented FEC-based congestion control. At the time, I think the feedback from the group was to pursue a generic path, which we never actually got to. Like, there was not enough excitement with the proponents, and the proponents have moved forward. So I think, just as a pointer, we would be submitting one more experimental draft soon for effect-based congestion control. It will perhaps not be generic. I think we can always have that discussion if we want to keep it generic. We'll probably bring an experimental draft, which we've been working on for the last few years. And so my question that relates to this is that now that we're seeing the proposed, the old proponents move their candidates forward into working group last call, are we still going to have the Rmcat meetings in case we bring this forward?
As far as I'm concerned, if we have things to discuss, we can meet.
Thank you.
And I think it would also be valuable to report back on the experiences in those meetings. So when people, I mean, both if there are new proposals coming, of course, that can be discussed at the meetings, and also if we have experience reports from the algorithms that are deployed, that would also be interesting for the working group to hear about, I think.
And with my other hat on, submit your experience report papers to the Applied Networking Research Workshop.
So do we have any more comments or thoughts about this part that anyone would bring up to the working group? Okay, so then we would encourage people to bring your experiences with algorithms, and if we can get real implementations and real experience, that will be very helpful, of course. But I think otherwise we close this discussion for now, if there are no other comments. And if so, we also close the meeting. So thank you all for attending and for your input. And please also help finish up and review the drafts that we still have in the pipeline. So we still also have some of the old work here to finish up while we talk about the next steps. So thanks all. And the blue sheets. Everyone signed the blue sheets? Otherwise, it's in the back. Okay.
Thank you.